We're going to now look at number patterns. This is probably one of the simpler, especially grade 10. Grade 12, they can get a little more complex, but essentially, there's once again, and I know you're probably, you know what I'm going to say, there's a recipe for it. Yes, there is actually. So, a number pattern, okay? Well, basically, let's call them a series, all right? Arithmetic progressions, arithmetic series. They are just basically a series of numbers, one behind the other one in front of the other, all right? And if you look at them, there's something linking all those numbers together. There's a formula that links them all together. So before we start this, okay, let's look at some definitions, right? This is now number patterns, all right? Number patterns. All right. Let's have a look. We see T, okay? And let's say it's T with a little 1 is put down there. This means it is term number 1. This is term, the T, and number 1. It is the first term in the series, correct? It's the first term in the series. That's all it is. Right. Then we say to ourselves, okay, then we see a thing comes up called Tn. That is the nth term. Okay? It's just a general. We don't know if we're talking about the 5th or the 10th, or how do you tell somebody? You just say, it's the nth one. In other words, at this point, I don't know, I don't care. We're going to build up a formula to find Tn. All right. So let's have a look at this. We could have, for example, Tn plus 1. What's that? It's the term 1 after Tn, isn't it? So if Tn was 6, or 7, is the 7th term. What is Tn plus 1? It's the 8th term. Right? So that's what we've got. Right? Then there's basically, we're going to come up with a formula. Let's first of all define, we're going to be looking at an arithmetic progression, an arithmetic sequence, an arithmetic pattern, an arithmetic series. So it's going to be arithmetic. Okay? The formula for this is this one. Tn is equal to a plus n minus 1. And I always put my d in brackets there. I'm going to tell you what this is. Tn is the formula for the nth term. Okay? Because if I can work out a general formula that tells me, I just substitute n in if I want the 7th or the 12th or the 50th term, don't I? What is a? A is always the first term. It is T1. D is equal to, this by the way is the arithmetic formula. Okay? Is only for arithmetic. Progressions. It doesn't work for anything else. First term, D is the first constant difference. Don't worry, we're going to go through these things in an example now, all right? And there's a few things we're going to look at, okay? We're going to look at, okay, a set of, first of all, linear terms and how to solve it. Then we're going to come to some specials right at the end. Okay, right. Now I'm going to give you here a recipe, right? Let's write it down. Step 1, okay? Step 1 is write down the series. So write down the series of numbers given and label the terms. As T1, T2, T3, etc. Okay? So we label all the terms. The reason why I want you to get into this habit is this. When we get to more advanced ones, right, they're going to leave out term 3 and maybe term 8 and ask you what they are, right? There's a way of doing it, but there's a recipe for it. Yes, there is. But the point here is that if you get into the habit of labeling the terms, when we get to those problems in grade 11, 12, it's already straightforward. You know how to do it, okay? We don't have to reinvent the wheel, so to speak. Okay, let's have a look now. We say right, and then label it. Step 2. Calculate the first common difference. Okay? All right? And remember, it can be negative. All right? Step 3. Check that it is the same for all differences. Okay? Step 4. Okay? Label it as D. Okay? If it's the same, label it as D. Right? And, step 5. Step 5, write down Tn equals A plus N minus 1 times D. Okay? And then step 6. Okay? Input all known values and solve for unknown. Okay? Very straightforward, really. Okay, let's have an example here. Okay? I've got here, they've said, work out the general term. The general term, okay, expression for the general term, or work out the expression for Tn, all right? They want you to work out that Tn equals. So, first of all, we write it down, minus 5, minus 10, minus 15, and minus 20. Label T1, T2, T3, T4, okay? We've labeled it. Now, underneath it, do this, okay? This constant difference here is going to be T2 minus T1. I'm now going to put it over here, okay? Okay, calculate the first common difference. I'm going to say it is T2 minus T1. So D equals T2 minus T1. But D also equals T4 minus T3. Therefore, D is going to be equal to Tn plus 1 minus Tn. In other words, it equals the term ahead and the term minus the term behind. Okay? Cool. Now, that's what we've said. Okay. T2 minus T1, etc. So minus 10 minus minus 5 gives me minus 5. Minus 5. Minus 5. Now, check. It is the same. Therefore, okay, because it's the same, it means what? It means that the series is actually an arithmetic one. Therefore, the series is arithmetic. Okay? Because that first common difference is the same. We're going to get to second common differences. Okay? That becomes a quadratic progression or series. But let's just look at this. It is arithmetic, right? In other words, we're either adding or subtracting one term to get to the next term, right? Okay, right, so we've got that, and it is therefore d equals minus 5, right? Then it says write down the formula. Tn is equal to a plus n minus 1 times d. Let us put in what we know, okay? Tn is what we're looking for. We're looking for the expression for the nth term, or the general expression for the series, right? A is what? A is always the first term. So if we've got a equal to the first term, in this case it is minus 5, plus n minus 1 times d is minus 5. All right, so then it comes out. Now we simplify. So I'm just going to go back and write in here, okay, Tn, input all known values, general all unknowns. Okay, what do? We, over here, we simplify, okay? All right. Because it looks a little bit messy. There's nothing wrong with that, but it's just awkward. So we say that is remove the brackets plus, hang on, brackets here, minus 5n plus 5. Remove the brackets, minus 5, minus 5n plus 5, which is minus 5n. Okay, so now we know that Tn, this is the formula, the general formula, for a series, isn't it? Okay, all right, well, so what? Now they've said, let's say they say, the question was, what is term 6? What does that mean? What are they looking for? Let's go back to the series, okay? Here it is, T5. They're looking for T6. So they're looking for where n equals 6, correct? That's what they want. They want term number 6. So therefore, n is going to be equal to 6. T6 is going to be equal to minus 5 times 6 is minus 30. Right? Then we go back and they say, which term is equal to minus 50? All right? Okay. Which term equals minus 50? What have they now said? They've now said that that is Tn. So therefore, this is Tn. We're looking for n now. So Tn is equal to minus 50, which is equal to minus 5 times n, correct? All right, I put that into brackets. It wasn't in brackets before, so let's just keep it as that. Therefore, I can work out what n is, because that is that. So therefore, n is equal to 10. We cannot have n equal to 0, nor n cannot be less than equal to 0. You can't have t minus 5, right? It just doesn't work in series that we've got, because that's not how we label it. We label it from the first one. That's the way we do it, okay? So let's look at this then. Now let's look at for example, let's look at a special case. In other words, I want you to just make sure that you look out for these. Look out for these, okay? This sequence here, okay? 1, 2, 4, 8, 16, all right? This is going to be, the series is 2 to the n. T1, T2, okay? T3, T4, all right? Where n over here, okay, they've allowed n to be equal to 0, okay? So let's just say, all right, let's just say for that case, n can't be or must be, okay? All right? all right? Because what I've got there, n can be 0. Because it lets me have a 2 to the power of 0 is 1, all right? Usually it would start with 2, 4, 8, 16, etc. That is 2 to the power of n, okay? These are ones that basically you just got to look out for. 2 is 1, 3, 9, 27, 81. This is 3 to the power of n, all right? Okay. I kind of don't like that one in there, although I see it in the books. I prefer it actually to be, because 3 to the power of 0, it means n can be 0. We don't have a 0th term, technically, okay? So, but just be careful of them because they are out there, all right? Can you see? For example, that is T0, 1, 2, 3. As I say, just there is confusion there. Series 3, okay, is 1, 4, 9, 16, 25. 25, okay? This is n squared. That's 1 squared, 2 squared, 3 squared, because that's T1, T2, T3, T4, T5, all right? Can you see we're starting T1s now, all right? This here is really, yeah. All right, but let's just say we've got 1, 2, 3, just so that we can 4 squared and 5 squared. The next one to look out for is 1, 8, 27, 64. Hello, that's n cubed, 1 cubed, 2 cubed, 3 cubed, 4 cubed, okay? So watch out for those numbers. They come up time and again, all right? And they ask us to work on those there. Let's have a look at this one. All right. Let's say they give us something like this. We're told the series, the general term of a series is the following. Tn is equal to 7 to the power of 2x minus 2. All right. Now they say, what is T1? What does that mean? That means n equals 1. Okay? All right. Can you see they've used an x on the top? All right. They should have said it's actually 2n. All right. Right? Can you see that? So actually it should be 7 to the power of 2n minus 2. And in this case, T1 is going to be 7 to the power of 2 times 1 minus 2. Please use brackets when you substitute in any time, is 7 to the power of 0, which is 1. All right. What term, okay, is equal to 117,649? Okay. So they're saying T what? Okay. They want to know n. So therefore, remember, Tn is equal to 7 times 2 to the n minus 2. They've given us that 117,649 is equal to 7 to the 2n minus 2. What is the target? It's a what kind of equation? Exponential. It is exponential. Why? We've got something in the exponent position, correct? So what do we do now? How do we do it? We get bases the same. 7 to the power of something turns out 6. Use a calculator to find 6, right? So therefore 7 to the power of 2n minus 2 is 6. What do we do now? We drop base, right? Typical exponential, drop the base. Therefore 6 is equal to 2n minus 2. And basically working that out, you get n equals 4. And can I check it? Of course, yes. Go back and put n equals 4 and see what you get. All right? You will get the answer, right? Now, let's say they give us these types of problems, right? Generally speaking, they're going to give you a sketch of something, a honeycomb or a matchstick thing. Let's say we've got this, all right? This is one of the classic ones, all right? This is a thing built out of matchsticks, all right? Like so. Okay, my drawing isn't great, right? And they ask us some questions. Find the nth term, or they say to us, calculate how many matches will be in the 50th term, or, right? Essentially, this or tiles or whatever are common problems, okay? The same kind of problem. It's a mathematical progression. It's a series problem. Now, when you get these, okay, please go 1, 2, 3, count them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Right? There's the series. Count them off. Tick them off. Why? Because you're looking at a figure with a hollow of sticks. It's very easy to miss one. Tiles, beads, whatever they do, it's very difficult to miss one. It's very easy to miss one. And then you end up getting a series that doesn't work and you get 0 out of 4 or 5. Please tick it off, all right? So that you're absolutely sure you've counted for it. The same thing, remember when we were multiplying out polynomials? Check that you've got everybody there, that they're all accounted for. So what do we do? First of all, T1, T2, T3. Therefore, check constant difference. That is going to be plus 2, plus 2. Tick constant difference. Therefore, D equals 2. Write down formula. Okay? A plus n minus 1 times D. A is first term. 3 plus n minus 1 times 2, which is 3 plus simplify, minus 2, which is 2n plus 1. All right? Now they then say to us, okay, let's say, I'm just going to do it here, how many matches, stroke tiles, stroke beads, stroke oranges, stroke whatever, dots, okay, will be in the, what have I got here? The 5th pattern. Okay. We then say T5 must be equal to 2 times 5 plus 1, which is 10 plus 1, which is 11. So there's going to be 11 matches in there, right? Now, the next thing they say, we have 100 matches. Okay. How many patterns can I build, or we build, right? So we've got a pile of 100 and we've got to build these. The first one's going to take 3, okay? The second one is going to take 5. Can you see that? All right? So we're actually, in effect, adding them up, aren't we? Right. But we've said we've got 100. Okay? So 100 is going to be equal to A, right? Which is, sorry, just use the formula straight off. 100 is going to be equal to 2n plus 1. Right? So now what? Right? I now say, okay, that's going to be, take it across, 99, 2n, therefore n is going to be equal to 49.5. What's my answer? Okay, what can I build? I can build 49. Okay, I can build 49. That's it. Because I cannot have, we cannot have a fraction here. All right? We don't get fractions over here. All right? Obviously, we don't. Because we don't, it's either a full pattern or it's not a pattern. Right? It can't, if it's supposed to have 4 blue tiles, it can't have 3 blue tiles. Then it's not the same pattern. It's something different. Okay? Let's look at this example here. Okay? They've told us 1 over 5, 4 over 7, 7 over 9, and 10 over 11. The initial tendency here is to subtract that from that, that from that, okay? There's a trick. Okay? What is it? Well, it's actually quite straightforward. It's 2 series. It's a numerator series and a denominator series. So numerator series 1, 4, 7, 10. Can you see it? There it is. It's plus 3 each time. And my other denominator series is 5, 7, 9, 11. Is plus 2, plus 2, plus 2. So there I've got T1, T2, T3, T4, T1, T2, T3, T4. Therefore, D is equal to 2, D is equal to 3. Now I can work out the general formula, right? The general formula for the numerator. Tn is going to be equal to A plus n minus 1 times D. That's going to be A is 1 plus n minus 1 times D is 3. So that's going to be 1 plus 3n minus 3, which is going to be, and I've got it over here, for the numerator, it's going to be the numerator 3n minus 2. Right? So the general formula for the numerator is 3n minus 2. Now let's look up the general formula for a denominator. Tn, remember, that's a totally separate thing. Tn over here is equal to 5 is A plus n minus 1 times D is here is plus 2. 5 plus 2n minus 2 is equal to 2n plus 2. Now it means that my series, the Tn for the series, okay, is Tn for the numerator over Tn for the denominator. Right? So, therefore, it is equal to 3n minus 2 over 3n plus 2. Now let's say they say, all right, what is T5? What is the fifth term? What do? You say T5 is going to be 3 times 5 minus 2 over 3 times 5 plus 2, okay, which is going to be 13 over 17. All right? All right? And if they say which term, here's another question. They say which term equals 19 over 23. Okay? Well, you know, therefore, the numerator is 19, so Tn for the numerator is 19. So 19 must be equal to 3n minus 2, because that's the numerator, isn't it? Or you could say that 23, the denominator, okay, 23 must be equal to 3n plus 2. This is the denominator. Okay, must be equal to 3n plus 2. And you calculate n over here is going to be equal to 7, and n over here is equal to 7. All right? Therefore, we've now, those are unusual ones, but they do occur. All right? I've seen them happen. You also get tile problems. All right? You get tile problems, right? Let's say we've got a block, right, like so, and we've got our tiles over here. All right, I'm just going to change it to colors. Red, blue and red. Blue is the outside. Whoops, there I go and make it red, which was a bit silly. I say red is then the inside one, and blue are these. All right, my next block looks like this. All right, for example, let's say it goes up 2. Can you see? there's 2, all right? And over here, I mean, I haven't got my dimensions cool, but basically what I've done is I've got now in the middle 2 red ones surrounded by blues, right? Blue. Okay, can you see there? Like that. And so on into the next one, where I'd have 3 reds surrounded by blues. How would you do this? You would first of all do a series for blue, which is going to be, it comes out over here as the series for blue, Tn is equal to 2n plus 6. You can work that one out, okay? And you do a series for red. Exactly the same as the numerator denominator. The series for red, Tn, comes out as n, all right? Therefore, okay, right. So you can work out how many red tiles, how many blue tiles, or total tiles is equal to red plus blue. The red is, let's just do it using the colors. Red, Tn for red, which is equal to n, okay, plus, okay, we go Tn for blue, which is 2n plus 6, right, which gives us what? We add them together, okay, so the total is going to be 3n plus 6, okay. This is then all tiles, all right. Those are the tile problems, all right. That was I mean, as I've said, these sessions are not meant to be, let's sort of like take our time, and it's informative, it's interactive. You're going through it with me. I'm just highlighting the recipes of how you do it and some of the key problems, okay? Types of problems that we're going to be solving when we see these in reality, okay? That brings us to the end of that one. We're going to go, next is going to be solving equations. We're going to go back to those, various types, and I'll see you in that session. Please just have a go at a few patterns. They're very simple. Cheers.